The question on page 235 states, an arrow is shot upward at an initial speed of 34.3 meters per second. When will it arrive at a height of 49? Okay. So what I want to know is how long will it take to get to 49 feet of height. So if I replace 49 where it says height, and I replace the rate of 34.3, and then leave the rest of it as it sits, I can actually solve for t. Now I know you're looking at this going, Lord, how am I going to factor something like this? Well, bear with me. It's going to be quite doable here, and I'm going to show that to you in a second. So I plugged in the height. I plugged in the rate according to the word problem, and then I'm going to solve. I'm going to add 4.9 over, and I'm going to subtract 34.3t over. Okay? So I'm going to have 0 equals, and I'm going to put it in the proper order, 4.9t squared minus 34.3t, and that's still positive, plus 49. Okay? Now they've actually done the work for you. Incidentally, 49, or 4.9, is a factor of all three of these. I know that seems a little crazy, but it's true. 4.9. And if you're not sure, if you see numbers like this in common, they're not trying to make this harder than it needs to be. 34.3 divided by 4.9. There it is. Okay, so you can see that 34.3 is divisible by 4.9. Okay, so let's pull out that 4.9. And we end up with t squared minus 7t plus 10. Isn't that nice? Much easier, right? Now you're automatically going to be able to throw this out, because if you remember, we're going to solve 4.9 equals 0 and whatever the factors are equals 0. 4.9 does not equal 0 in any realm. So you can throw it out as part of what we're going to solve with. Looks like it's t minus 5 and t minus 2. Would you agree with me? T minus 5, t minus 2. Solve all three pieces for 0. 4.9 equals 0? No. Ignore it. T minus 5 is 0, so t is 5 seconds. T minus 2 is 0. T is 2 seconds. Well, wait a second. How on earth could this arrow be at 2 seconds at 49 feet and then again at 5 seconds? Any ideas? Ha! No physicists in the room. Okay, so I'm going to fire my arrow upward, right? And because of gravity, it is eventually going to fall back down to the ground, isn't it? So if this is 49 feet of height, 49 meters, I mean, of height, then it is at this point and at this point that my my arrow will be at that height. Okay? That is why you get two answers. So 2 and 5 seconds is going to be your answer to that one. Okay? So just understand that when you're firing a rocket's going to go, depending upon, even if it's shot for a far distance, it's going to start here and it's going to go, whatever. Okay? Gravity will act upon that object and force it to return home. Go ahead and turn to page 236, and I'm going to do number 17 with you. This is number 17 from page 236. Number 17 says, a ball, okay, so we're not dealing with an arrow or a rocket, we're dealing with a ball. A ball is thrown upward with an initial speed of 24 5/10 meters per second. When will it be 19.6 meters high? And there are two answers. Notice in the bowl above, it gives you the formula for meters and it gives you the formula for feet. Okay, because depending upon if they give you the data in meters, you use the meter formula, which is the one with the 4.9. And if it's in feet, you use the feet formula. That's the one where it's 16. Okay, and that's just because the measurement unit type is different. Meters are different from feet. Okay, so number 17, a ball is thrown upward with an initial speed of 24.5 meters per second.
Okay, the following students to the office, please. Tiana, Zoe, Jewel, and Veronica.
When will it be 19.6 meters high? Which formula are we going to use, the 4.9er or the 16? 4.9, so I'm going to write it. Height is equal to rate times time minus 4.9 times squared. All right, when will it be a certain height? So the height of 19.6 will be achieved at a rate of 24.5 multiplied by time minus 4.9 time squared. Okay? The 19.6, the rate, and we're going to solve it. We're going to zero the equation out by adding the 4.9 t squared and by subtracting the 24.5 t. Okay, here we go. So 4.9 t squared minus 24.5 t plus 19.6 equals 0. Well, let's see. 24.5 divided by 4.9. Yes, okay, this is divisible by 4.9. Let's see if this is. 19.6 divisible by 4.9. Hallelujah. All right. So that's always my hope, because this is not easy. Imagine trying to figure out factors of this whose sum is this. Nah, they're not going to make it that hard. 4.9 t squared minus, shoot. Well, this one's a 4. So 24.5 divided by 4.9 is 5. 5t plus 4. Factors of 4 whose sum is a negative 5, t minus 4, t minus 1. And 4.9. Solve for 0. Which one can I throw out off the bat? Yes, because when you say 4.9 equals 0, that's automatically false. Eliminate it. But t minus 4 equals 0, so t is 4. T minus 1 equals 0, so t is 1. So that means after 1 second heading upward, 4 seconds going down. 1 and 4 are going to be your solution set. If you were doing the assignment out of the book, number 19 would be the 16. You would use the feet formula, because number 19 has the feet formula. All right, questions about yesterday's odds, and then I'm going to give you the worksheet. I know Michael had one for sure.
Number 11.
11, what else from yesterday? 15? 7? Trying to write them in order. Going once? Sold. All right. So here's yesterday's assignment. I'm going to go in order. I'm going to start with number 7. The sum of the squares of two consecutive positives, positive evens, is 340. Find the integers. So this is 7. So this is an integer. This is the next even. Would you guys agree with me so far? This is an integer. This is the next even. It would also be the next odd because it has to do with where you start, right? Now, the equation says this. The sum of the squares of two consecutive positive evens is 340. What are they? Okay? So this is integer 1, this is integer 2. The sum of the squares is 340. All you got to do now is square everything, collect, combine, zero out, and solve. One thing I'm noticing a lot of you are doing wrong. When you square this, you're not foiling. You're coming up with an answer of n squared plus 4. That's not right. It's n squared twice the product of a and b, which would be 4n, and then 4. Okay, you've got to foil it. I keep writing it on your papers. For some reason, you're not doing it. Got to foil it. Or remember that the pattern when you're squaring up there is a squared twice the product of a and b, which this is a, this is b, and b squared. Anyway, n squared plus n squared plus 4n plus 4 equals 340. Stay with me, Noah. 2n squared plus 4n. If I subtract this 340 over to the 4, I end up with negative 336. Okay, that combines these two pieces. Okay, a negative 340 with a positive 4. Any greatest common factors that will allow us to reduce this mess? 2. Let's pull that 2 out. 2. N squared plus 2n minus 168 equals 0. Okay? Factors of 168 that have a difference of 2. Ugh. Let's see. 168 divided by 16. 168 divided by 18. See, I'm just hunting and pecking right now. Divided by 14. 14 and 12. Cool. So I hunted around until I found an even factor, at least something that was an integer. And if I divide by 14, I get a 12. 14 and 12 do have a difference of positive 2 and can create a negative 168. So it's going to be n plus 14, n minus 12, and 2. Solve for 0. Which piece are you going to throw out? Yep, 2 equals 0. False. Throw it out. N plus 14 equals 0, so n is a negative 14. Interesting. That's this piece. N minus 12 is 0. So n is a positive 12. So the answer is 12 and negative 14, right?
You can't have a negative.
It's looking for consecutive positive evens. So a consecutive positive even does not include a negative. Throw that out. Starting with 12, the first number is 12. The second number, 12 plus 2, is 14. Okay? Any questions on this one? All right, that was number 7. 11, 13, and 15. Here we go. 11. I'll try and go fast, guys. That's on the next page. Find the dimensions of a rectangle. This one's fun. Yeah. Find the dimensions of a rectangle whose perimeter is 46. So 2L plus 2W is 46. Okay? Length, length, width, width is 46. And whose area is 126. LW Well, what am I supposed to do with this? I can't set this up. Bear with me as I show you how to do it. If I take this equation and I solve for W, it'll look like this. 2W equals 46 minus 2L. That should be an L. Divide everything by 2. And I have W is equal to 32 minus L. Are you with me so far? All I did was solve for W. I know that doesn't tell you anything, but I solved for W. Okay? What if I take this value and plug it in right here? Because this is W. W is 32 minus L. I've just shown you. Length, because in a rectangle there's two lengths, and width is 46. I moved my L's, divided by the coefficient, and solved for W. If I plug in the value that we believe is W in the W position, it'll look like this. L, 32 minus L is 126. Isn't that interesting? Length times width. Multiply, collect, zero out and solve. 32L minus L squared is 126. I'm going to bring everything over so that I have a positive L squared. And I now have 0 is equal to, I'm going to put my square first, L squared minus 32L, and that stayed positive, plus 126. Solving. Factors of 126 whose sum is a 32. Nine and 14. So L minus 9, L minus 14. Okay. L minus 9, L minus 14. Negative, negative. Okay. So L minus 9 is 0. L minus 14 is 0. L equals 14. L equals 9. What in the world does that mean? Which one do I choose? Yes? Say again? I wrote 23. I mean, 46 divided by 2 is 23. 23. That's hilarious. Thank you. A little bit of dyslexia never hurt anybody. 23. Thank you. That's funny, and I saw it the whole time, but I just kept saying 23 in my mind. Okay. Thanks, Benjamin. Okay. 14 and 9. So which one do I choose for length? Which one do I choose for width? Does it matter?
Yes.
Incidentally, it doesn't matter, because 14 by 9 is the dimensions. Okay? So if you want to call this side the width, that's fine. It really, width and length terminology is merely utilized for you to understand if you believe something is going this way or this way. But if I take this and I turn it like this and I say this is width, or I turn it this way and I say this is length, it doesn't change the rectangle's shape at all. Okay? 9 by 14 is your answer to number 11. 13. Yes, I use a lot of paper. The sum of two numbers is 25, and the sum of their squares is 313. Okay. In order for me to have two numbers whose sum is 25, I'm going to call the first one x, and the second one 25 minus x. Would you agree with me that that would create a situation where two numbers must equal 25? Let's just pick at it for a minute. Let's just say x is 1. 25 minus 1 is 24, right? Is the sum of these two numbers 25? Okay, so algebraically, this indicator identifies two numbers whose sum is 25. The sum of two numbers is 25, and the sum of their squares is 313. Okay, so x squared added to 25 minus x squared is 313. Okay, from here, we're going to square everything, collect, zero out, and solve. This is x squared. So 25 squared is 625. Twice the product of a and b is a negative 50x, and negative x squared is x squared. Nice, huh? Running out of room. So it's going to be 2x squared minus 50x, and then let's bring our 313 over by subtracting it. So I'm going to have, it's going to be a positive 2, 1, 3. Okay, all of that equals 0. Pull out your 2, and you know you're going to throw it out because 2 doesn't equal 0. And you get x squared minus 25x plus 156 is 0. Factors of 156 that result in a negative 25, which means one of the factors is 25 larger than the other. Or 20, no, it can't be. No, because it's a negative negative. 12 and 13. X minus 12, x minus 13. And guys, this is where you're just going to have to hunt around for factors. Okay? So the answer, after I solve, 2 gets thrown out, is going to be 12 and 13. Okay? 12 and 13 combined do equal 25. 12 times 13 multiplied do equal 313. Okay. Last one. This is number 15. Originally, we had a 20 by 23 rectangle. I'm just going to draw it. When both were decreased by the same amount, so I'm going to call that amount x. When both were decreased by the same amount, the area of the rectangle decreased by 120. Okay. The area of the rectangle decreased by 120. Okay, so this here is the change. This is really similar to what you guys did before, only before these squares canceled out. So the change of the rectangle is equivalent to the large minus the small. Would you agree with me? That if I took the area of the big one and I subtracted the area of the small one, that would leave me with this shaded piece? Well, let's go ahead and straighten this out. The change is 120. The large rectangle's area is 20 by 23. How do I know that? 20 by 23. The small is 20 minus x multiplied by 23 minus x. Okay? Solve. So it's going to be, first is going to be 460, outside negative 20, inside negative 23, so negative 43 x. And last is a positive x squared. You guys seeing all that? All right, so this times this is that, negative, negative, that, positive. But this negative has to be carried over all those pieces, which means all my signs are going to change. This is a negative, this is a positive, this is a negative. 460 equals 120. Okay, the 460s cancel. That's nice. Got this 120 laying over here. Let's move our x squared by adding it, and our 43x by subtracting it, all over there. X squared minus 43x plus 120 is equal to 0. Factors of 120 whose sum is 43.
Negative 3 and negative 40. Yeah. Negative 3 and 40.
I did something wrong. 17. Whoops.
Well, it's because a difference of negative 40 is way too big, so there's a difference.
Give me a second. I made a mistake somewhere. Yes, I did.
I solved it the correct way doing this.